Okay. So now we're going to do one where we actually evaluate it. Okay. So remember, if you're doing an integral dx, dy, dz, dx, whatever, whenever you're doing the integral with respect to y, you only care about the y, so you don't care about anything else. Okay? You're not integrating something, any of the other variables when you're talking about y. Okay? So we're going to do the integral with respect to y first. So what is the integral of sine? So remember, the rules are kind of backwards from your derivatives. So the integral of sine is negative cosine, because the derivative of cosine is negative sine. We have to let those cancel each other out. So this becomes the integral from 0 to the square root of pi. Okay? The integral from 0 to x of x squared. Now, negative cosine of y evaluated at 0 and xz, okay, dz dx. Okay? So now you're going to plug in xz and 0 into this. But remember, cosine of 0 is 1. So that becomes the integral from 0 to the square root of pi, the integral from 0 to x. Now this is going to be negative x squared cosine of xz. And cosine of 0 is 1. But remember, we're doing subtraction, it's already negative, so that's plus x squared dz dx. Okay. Right. Now ignore all the x's. Okay? And we're just going to do an integral with respect to z. Okay? So if this x squared right here is just being treated as a constant, what am I going to get? I'm going to get x squared times z, because the integral of a constant with respect to z is just going to be that constant multiplied by z. Now when I integrate the negative cosine, if I'm viewing that x as being a constant, what am I going to have to do? I'm going to have to divide by it to counteract the chain rule. Okay. So this is going to equal the integral from 0 to the square root of pi. Right. Now, negative x squared sine of xz. But remember I said that we're viewing x as a constant, so we're going to have to divide by x. And then plus x squared times z. Now this has to be evaluated at 0 and at x. And then we're going to have to, once again, integrate with respect to x. But whenever I replace the z's with the x's, I mean, this z and this z with that x, everything is going to be in terms of x. So that allows me to integrate with respect to x. Okay? So, well, x squared divided by x, well, that's just going to be a negative x. If I plug that x into there, that's going to be x squared. And sine of 0 is 0, and if I plug 0 into x squared times z, it's going to be 0. Okay? Ugh. You know what? I'm going to break this into two integrals. Okay? Why I'm going to do that is because I need to do a u substitution. So for this guy right here, I need to use a u substitution. And so I'm going to let u equal x squared, so that du equals 2x dx, or that du divided by 2, still on the screen, equals x dx, x dx, x dx. All right. Now, remember from all the way back in Calculus 1, when you do use substitution, your boundaries have to change. Okay? So if I plug the square root of pi into this thing, I'm going to get, well, square root of pi squared, which is pi. And I'm going to start a new page. So, this ends up becoming the integral from 0 to pi of negative sine of u and then du divided by 2 plus the integral from 0 to the square root of pi times x cubed x. Okay. Now remember, I'm going to integrate sine again. And remember, when you integrate sine, it changes sign. So this will be actually positive cosine of u divided by 2, evaluated at 0 and at pi. And this guy is going to be x to the 4th divided by 4, evaluated at 0 and square root of pi. Okay? Now cosine of pi is negative 1. So that would be negative 1 divided by 2. And then cosine of 0 is 1, but we're subtracting to minus 1 divided by 2. And if we take the square root of pi to the 4th power, that becomes pi squared divided by 4, which equals pi squared divided by 4 minus 1. Okay. So that's why when you're doing these problems, right, so how did this problem begin? We'll leave that up there. So this problem began as an integral with respect to y. Okay? Now, since I began the problem as an integral with respect to y, I needed my boundaries to be a function of x and z. I mean, it doesn't have to be, but I mean, it could just be a function of x or a constant, whatever. Okay, so then once I integrated with respect to y, then I have to have my boundaries. If I'm going to do a dz, I have to have my boundaries in terms of x. So that when I finally do the dx portion of the problem, I can just plug numbers in and I actually get to an answer. Okay? So you want the final integral to actually get you to a number rather than some type of function, something like that.